Professor Shivani Agarwal, welcome to the India at Harvard podcast. We are delighted to have you here. You are a professor of computer and information science at the University of Pennsylvania and also professor of statistics and data science. We're delighted to have you here to talk about machine learning today. You've led some projects as well across US and India, so it will be really interesting for our audience to hear about some of your work and research. We'll also talk a little bit about the future of R&D and machine learning in India. Thank you for giving us your time today.
Thank you so much, Priyanka, for having me here. It's a pleasure to be with you both.
Thank you. So, Professor Agarwal, it's good to start because we have an audience from really all over the world of different fields and domains. So, it's always good to start with the question of what is machine learning and why are we talking about it today? Does it matter?
So, yes, Priyanka, so at a high level, machine learning is a field of study that makes use of machines, specifically computers, to turn data into actionable insights. Historically, the field can be thought of as having evolved, in the late 1940s, early 50s, started there. Although many of the tools used in machine learning can be traced back to earlier, it has become increasingly important, as you say, in recent years, because really data is everywhere these days. There's financial data, there's retail and e-commerce data, there's medical data, there's cell phone usage data, there's travel data, there's astronomical data, geological data, you name it, biological data. And the volumes of this data make it very difficult for humans to process and make sense of it directly without the use of computational tools. And that's basically where machine learning comes in. So, more precisely, machine learning is an interdisciplinary field of study at the intersection of computer science, statistics, and mathematics. It involves the development and study of computer algorithms that can learn patterns from data and can use these patterns to make predictions or inferences about new, previously unseen data. So, for example, after seeing a lot of financial data containing both examples of genuine financial transactions and fraudulent financial transactions, a machine learning algorithm can automatically learn a model that can predict with high accuracy whether a new, previously unseen financial transaction is fraudulent or not. As another example, after seeing data about various customers and, let's say, the movies they have watched or liked, a machine learning algorithm can automatically learn a model that can predict with high accuracy which other movies various customers might like or enjoy. So these are just a few examples. Of course, there are many, many more.
No, that's great. Thank you for setting that context, Professor. Of course, the field, as you were trying to tell us, historically has developed. My understanding is largely out of the US first. But as you know, that we try and bring the context of our conversations to India as well, and how some of these fields might apply to the Indian context. So, we wanted to ask you, how do you see the field developing in India? And what are some of the applications you are seeing evolving for machine learning in India that might be, very relevant today?
Absolutely, Anirudh. So, this is a great time to be working in machine learning in India. There are lots of applications. I'll mention a few in a moment. There are lots of applications. There's obviously data everywhere and it needs to be made sense of. So, in addition to, for example, the financial sector that I mentioned before, financial fraud prediction, for instance, there's, more and more financial transactions nowadays are taking place digitally, right? Whether it's on the computer, whether it's on the phone, and they're all leaving huge amounts of data that can be analyzed to understand, how consumers are using these tools, what kinds of behavior patterns there are, what might be a fraudulent, activity, and so on. So there's lots of opportunity there to make predictions to understand, right, in finances. There's all the personalization of services like entertainment services and retail services that I mentioned, movies, books, shopping, all sorts of things. Those are, of course, there. There are many others. Security is one. So, if you're using things like facial recognition systems, biometric recognition systems, and so on, these are all heavily dependent on machine learning techniques to make predictions about whether, is this person, a particular person from a database, is this biometric, one of those that should be looked at, and so on. There's cybersecurity. Increasingly, a lot of work is being done by AI agents, for example, and these are opening up new types of security issues, right? Security concerns and so on. And so there's a lot of, again, all of these involve data, and so there's a lot of scope for learning automatically, for processing, analyzing this data using computational tools. And of course, it's an evolving field. Many new computational tools still need to be developed, right, to be able to catch all these kinds of things. So there's lots of research to be done there. Language. So in India, we have so many different languages, and you've probably heard about large language models that make use of deep learning techniques, which is one type of machine learning approach that has become very popular in recent years. In India, we have so many different languages, and the current methods, large language methods, are trained on massive amounts of language data. In the English language, there is more digital data available in some sense to process this. In India, there's a huge need to be able to translate things across, right? Machine translation, various kinds of understanding, interpretation, and so on. Both for things like old text that would be nice to have available. Wouldn't it be lovely, right? If you were interested in, let's say, Tamil literature, and but you didn't understand it, you hadn't grown up speaking that language, and you wanted to be able to, understand what some famous Tamil poet wrote. Wouldn't it be beautiful if you could just pick up some, Tamil book and just have some kind of scanning system, and suddenly, you can read it in Hindi, in Sanskrit, in English, in Bengali, whatever you prefer, right? And also in various states, the legal documents are in local languages. So in Karnataka, for example, if you go and buy property, right, and you go to the registrar's office and register your property, you'll receive a certificate, that says you own this property. But if you don't speak Kannada, you won't be able to understand. There's a lot of text there that's not, only a few things might be also written in English or something, but a lot of it you will not even know. Your
That's
own
right.
ownership certificate, you don't know what it's saying. Wouldn't it be
Yeah.
nice if you could use some scanning tool and be able to parse it, right? In whatever language you like. And there are
Yeah. No,
challenges.
in fact, just today, sorry to intervene, I saw a call for researchers to leverage AI to help decipher the Indus Valley script, which of course remains undeciphered
There
so
we go.
far. And so,
Yeah,
to your point around, not just languages that we, of course, know the script of, there's possibility that maybe AI will be able to help us crack that script that has remained undeciphered for centuries now.
that would be fantastic. The catch being, though, the volume of data. Do we have enough data to make that happen? And then,
That's right.
can we somehow improve or fine tune these methods to work with lower volumes of data, to augment the data in some way that allows learning to happen? Perhaps not at the same level of accuracy as you would get with larger volumes, but still something that is reasonable, right? Reasonable. Like, lots of questions there. Then there's the medical and life sciences, right, which is something that I'm also quite passionate about. Precision medicine, where we'd like to be able to make more accurate predictions for individuals, right? Be able to, really customize and tailor treatments for, especially in complex diseases. And so there's lots of scope to use machine learning techniques to improve. And the thing with India is, at least with individuals, with people, with patient data, for example, the volumes in India are actually larger on our side. So unlike the languages situation, which might, the reverse, here we tend to be able to have more data. So those are interesting opportunities, Anirudh.
Tell us about, I mean, you've said that you're really passionate about life sciences and the medical industry. So tell us maybe about one or two projects that you've worked on in India. That would be, I think, very interesting to hear about sort of what tools you use, what the process was, and kind of what the impact was from some of these projects.
Sure, Priyanka, absolutely. So a lot of my work actually focuses on foundations in machine learning, which includes, understanding various types of machine learning, analyzing and understanding various types of machine learning problems and designing new algorithms for them. I also enjoy working on applications of machine learning, particularly in the life sciences, and also exploring connections between machine learning and other disciplines. So let me mention here maybe briefly a couple of projects related to the life sciences that I worked on during my time when I was a faculty member at the Indian Institute of Science, which is now more than 10 years ago, or about 10 years ago. So the first one has to do with precision medicine in the context of cancer, specifically predicting anti-cancer drug response in patients. And the second one has to do with predicting survival of patient survival in intensive care units and ICUs. So the first one, precision medicine in cancer. So for complex diseases like certain types of cancer, doctors are faced with a challenge that patients who present themselves with similar symptoms, similar diagnostic results, right, similar, perhaps genetic markers and so on, given the same treatment, often respond differently, right? They have different outcomes. And so a question here is, how can we better predict how a particular patient will respond to a particular treatment, in order to be able to use the patient's valuable time and resources with the in an optimal way, as optimal way as possible. So we worked in a collaboration with medical scientists toward this. In particular, we worked on some data with head and neck cancer and colorectal cancer. So the model was the following. There were ex vivo cultures from patient biopsies, where a biopsy is taken from a patient and is cultured in a medium that mimics the environment inside the patient's body. So you might be familiar with in vivo, which is inside a living organism, and in vitro, which is in let's say a glass petri dish or a test tube outside. Ex vivo is something in between. Right? It takes a biopsy from the patient, but grows it, cultures it outside. So then the drug under consideration for the patient is administered to this culture. And the interaction between that tumor biopsy and the drug is observed for some time, and some biological readouts are taken. Okay, so this is the data that's obtained for patient. And so the goal here was to try to predict, in particular, there are three clinical outcomes that were of interest here. Would the patient be a complete responder? Would the cancer regress completely? Would they be a partial responder? Would the tumor at least regress partially or stabilize, or non-responder, meaning that the treatment does not work for them. And so we had some data with labeled examples for certain patients. And what we ended up doing was essentially using a variant of an algorithm we had developed in our research group, because here the errors in the two directions are of different costs in some sense, right? So false negatives are more costly than false positives. You don't want to miss a treatment for a patient if they can benefit from it. And so based on what we were advised by the medical collaborators, we ended up using some machine learning techniques we had developed in our group. And it turned out that based on the previous approaches of genetic biomarker-based selection, so for colorectal cancer, for example, only about 30% of the patients who would be given a particular drug were actually responding in one way or the other. For head and neck cancer, it was around 67%. In the small sort of pilot study we did here, after using the machine learning selection, we were able to achieve, so out of the patients recommended by the machine learning method, around 94% of them were actually responders. So we were able to increase that significantly. So that's one. I know we're a little bit out of time, so I will just very briefly mention the other one and not talk a lot about it. Yeah, the second one was basically predicting patient survival in ICUs. So this was in collaboration with St. John's, the critical care division at St. John's Medical College in Bangalore. They were interested. So in the US and Europe, there are certain types of score systems that are used to predict patient survival in ICUs. Okay? This helps to make decisions about patient care. It also helps to evaluate the quality of care in ICUs. However, these score systems they were either created manually with certain parameters, or they were semi-trained on Western patient data. When these are used on other patient populations, such as the Indian patient population, they don't perform as well, quite naturally. And so we were asked to help develop a machine learning approach to automatically learn such score systems from patient data. And so we did this. We designed algorithms to learn score systems of the type that doctors were familiar with, that they were comfortable with using machine learning methods. And again, these outperformed existing score systems for this task. So these were just a couple of examples. Again, as I mentioned, I think there are lots of opportunities in India for using machine learning in the medical and life sciences.
No, that's very helpful. I think it gives us a more micro picture into how some of these research projects work. Now, the other vantage point that Shivani, we wanted to ask you about, you've had the benefit of having worked in two different research ecosystems. You mentioned having worked at IISc, the Indian Institute of Science, many years ago, now almost over a decade ago. You've been at now Penn for some time. Um, Talk to us about, you're also mentioning about how customization, about sometimes systems developed in the West might not work in India. And of course, that points to a very clear gap, right? That you need to do more R&D focused on India, in India, using R&D data from, let's say, clinical data or observation data from Indian patients, etc. So the broader question I wanted to ask you was this. In the research ecosystems that now you've been part of, if you were to compare them and you were to evaluate where the gaps are in the Indian R&D ecosystem, talk to us about that. How can those gaps also be plugged? I know that's a big question, but that's been a big topic of, I would say, conversation in India as India starts to build out its own R&D ecosystem more. The Anusandhan National Research Foundation has been announced recently. Fair bit of budget outlay has been put towards it. But I wanted to, given that you are deep into these research ecosystems, get your views on that question.
Sure, Anirudh. So let me interpret this question as asking how would we try to strengthen the R&D ecosystem in India, let's say, and uh, perhaps specifically related to machine learning, but I think many of the thoughts would be applicable to other research areas as well. So maybe just broadly, how do we strengthen? So, you know, there are several components to a strong R&D ecosystem in any country. Let me perhaps mention three main ones that come to mind. So the first perhaps would be the pipeline. So this is like the early education system. So schooling, I would perhaps also include some parts of undergraduate education. Then there's the part where research is inculcated and talent is cultivated within the research sort of scope. This is the higher education sector, right? So this would include your postgraduate, doctoral programs, perhaps postdoctoral, and so on, more specialized work in research. And the third then would also be the investment community, right? That helps to translate research ideas and prototypes to more immediate practical societal and economic gain. So, in terms of the first component, early education, the pipeline, I would say in many ways, for machine learning at least, right? In many ways, in India, the quantitative sciences training, the training in quantitative fields in general is quite strong, let's say. So in the US, for example, there's a lot of focus on programs to encourage young students, potential later on to be researchers and entrepreneurs, to work in STEM fields, science, technology, engineering, and medicine fields. So I would say in India, there's a tradition of quantitative training, engineering, sciences, and so on. They would say there is room for building more, even early on, building more intuition, lateral thinking, which are important components for getting into research later on. But by and large, I think a lot of good things exist. In terms of higher education, there are, of course, many strong institutions and programs in India. The Indian Institute of Science, where I previously taught, being one such institution. But for a country of the size of India, there is clearly a need for many, many more strong institutions of higher learning and research. And I can talk a little bit more about this if you're interested. This is probably of the three, this is probably the component that I'm most qualified to say more about. Finally, another critical component is a strong investment community. The investment community is important not only for providing funding to take seed ideas and prototypes, right, to develop new research into tangible products, that have more immediate societal gain, financial gain, and so on. It also is something that provides mentoring opportunities, networking opportunities to the individuals and startups that might be engaged in this R&D activity. My understanding is that the investment community in India is relatively young compared to the US, but it has come a long way, let's say, compared to 15 or 20 years ago. And I think it's growing strong. So I don't know if this answers everything you wanted me to talk
No, it
about.
does. It does.
Yeah.
But please feel free to spend a couple more minutes on the second piece that you said you are most qualified to talk in detail about. Please do.
Sure. So you're talking about the higher education component, the higher education and research component. Right, absolutely. So there's laws that could be said here, but let's try to keep this, contained and short. There's often a debate about, you know, how do we okay. So the second component is higher education, and the question is, so clearly there's a need for many more in a country the size of India, many more strong institutions of higher learning and research in order to build a stronger R&D ecosystem there. The question is, how do we go about this? How do we achieve this, right? And there's often a debate, should this be done by the government sector? Should this be done by the private sector? How much should each do? How do we make this happen? I would like to actually bring in a third sector. Perhaps it could be viewed as part of the private sector, but I'd like to bring the third sector. And that's the philanthropic sector. The reason being, government. So my understanding, when we say the government sector, we're talking about institutions being perhaps created and certainly continually funded by the government. Right? When we talk about the private sector, it can have various shapes and forms, but in many cases, the interpretation, certainly in the Indian context, is that it is largely a fee-based model, right? So in the sense that the continual funding that's needed to run the institution, right, whether it's the salaries of staff, faculty, and so on, whether it's the buildings, whether it's the maintenance of the ecosystem, whether it's opportunities for the students, whatever it is, the source of income tends to be the fees, right, from the programs that students are enrolling in. And this can, of course, also help with certain amounts of research, but it cannot go all the way to creating the kinds of research institutions that we are talking about. The government, in the discussion, the government is not a foe, not an enemy. The government should be viewed as a friend. And I think the government has been trying to do its part in many ways over the last several years. They've created these new Indian Institutes of Technology, IITs, new aims for medical sciences, new set of institutions, Indian Institutes for Science, Education and Research, and many others. This is what the government knows how to do, what they can do, and they're trying. I don't believe that it's the government's mandate to create, let's say, a Stanford University or an MIT. Right? That's not how these universities were created. So many of the prominent universities in the US were, in fact, founded through philanthropic endowments. And they continue to have philanthropic endowments as a substantial source of their continual income or funding. And so if we wanted to build more strong institutions in India of a similar flavor, customized to Indian needs, sure, perhaps, but we would have to look to similar models. In fact, let's share an interesting observation here. The US became independent in 1776. Right? There were, of course, many universities at the time. Harvard was founded in 1636. Several of the Ivy Leagues were founded in the 1700s. The University of Pennsylvania, where I work, around 1740. Princeton University, I think, in 1746. Many others. But as the US approached its 100th anniversary of independence, right? So between, say, 1860 and 1890, even beyond, but particularly that period of time, 1860 to 1890, there was a huge wave of creation of new universities for research and higher education here in the United States. In fact, so MIT, for example, was formed in 1861. Stanford, I believe, was formed in 1885. And there were many other universities that came up at that time. Some of them were state universities, not federally created, right? But many of them were philanthropic universities, and these are still today powerhouses. Right? So, we're in 2025 right now. In a couple of years, India will celebrate its 80th anniversary of independence. Here's a thought. Could we have a vision for the next 25 years? Let's say a vision for 2050, which would be just after India will have celebrated its 100th anniversary of independence. Could we have a vision that in the next 25 years, we in India create 25 or more new, strong, vibrant institutions for higher education and research that have right from the start, um, research and translation, and not just research and translation, cutting edge research and translation, right, as part of their core DNA right from the start.
Yeah.
And it can be done, I mean, way back in 1909, when the Indian Institute of Science was founded, right? I mean, today its funding comes largely from the government, but it was founded by Jamsetji Nusarwanji by J.N. It was founded, a large part of it was through his philanthropic endowments. Right? There were also other sources, but that was a large part of it. And imagine at that time, pre-independence, how hard it must have been to achieve this. Right? So it can definitely be done. So are there 25 individuals or groups of individuals who, that's what it would take, the 25 individuals, groups of individuals who are committed to each leading the creation of a new university of this type, a new institution of this type in India over the next 20 to 25 years, starting now, I guess.
Yeah. Would that also help Shivani help solve the um, problem that my sense is India faces, which is that it's top tier research talent. Let's say you and many others who've come through the education system, who end up going abroad because the ecosystems abroad are, one can argue, much more vibrant, much better funded. Would what you are recommending, the setting up of, let's say 25 or more research focused universities with a clear mandate, would that also help solve that talent problem, or is more needed to be done to solve that talent problem also?
If those kinds of ecosystems were created in India, Anirudh, if individuals could do and live the way, do what they do, in different parts of the world, if they could do all that in India as well, right, with, you know, so this is perhaps a topic for more discussion as well at some point later on in terms of what exactly is it. Many times people don't understand why is it, right? But in some sense, if you're looking for individuals to bring in, in some sense, it's like somebody who may be speaking, one language beautifully, perfectly, right? But if you're looking to do translation, if you're looking to do cutting edge, whatever, if you're looking to do more, then in some sense, you need to be able to speak more languages, right? You need to, and then there are ecosystems that make that easier, and there are ecosystems where that's a little harder, right? And so if those ecosystems existed and people could do that freely, right, and create, then I don't see any reason why that would not help. I mean, I think that would be helped tremendously. Um, you know, would everybody who's going outside the country, now choose to say, of course not, and it shouldn't, right? There should be free flow, and in the other direction too.
That's
Creation
right.
of such institutions within India does not mean that these are limited to only, just as we are, all benefiting from an international exposure, we should also be able to create that in India, right? Where talent from other places comes, and we are able to help nurture talent for other parts of the world as well. We don't want to be just focusing only about problems in India. While we're at it, we can actually solve problems for many more. Why not?
And also the pollination of ideas, for example, like you sitting out of University of Pennsylvania and going back to India and then having that duality of experiences and research also helps. So it's not always that we want the reverse brain drain to be completely in favor of India as
Right,
well.
absolutely, absolutely. But I do think that the right now the balance is so skewed in some sense. I do think that that would definitely help to even it out.
I think just one last question and then we can close. But spoke about the importance of the philanthropic sector to meet the needs of that financing, their critical role, and then also, of course, government and its ability to shape some policy to facilitate these machine learning and AI and these fields of R&D. What about the private sector? How do you see their role now to facilitate these local innovation ecosystems and R&D in India?
And so I didn't get the last part, Priyanka. Did you say
The
the
private
private
sector
sector?
role.
So when you say the private sector, I want to just make sure I understand exactly because as I
Corporations, just companies, big technology companies.
okay, industry.
as well doing financial services, could be software companies like Infosys. What could be their role in facilitating more local innovation ecosystem forming across India? And could be tier two cities, tier three cities as well.
Right. So I don't pretend to have like some deeply thought out answers to this, but I think it's different for each industry, for each company, for each situation. But one way, of course, is the employment opportunities they're creating, right? Which already to a large extent exists, right? So a lot of these industries that this is true for any field, but for example, in machine learning, many of these companies, when they're using machine learning techniques or other computer science techniques or other whatever other field you might be interested in talking about, when they need high-end expertise in these areas, they are employing graduates of institutions around them, right, locally. That's one. That already creates a demand within the system and so on. In terms of doing more, so I think so in addition to existing, let's say larger companies in industry, I think that this creation of new entities through interactions, networking, and idea translation between the academic sector, between, industry, between the investment community and so on. I think there's a lot more opportunity for new ideas to be translated to the new companies, right? Just as you mentioned, a lot of, you mentioned that a lot of the developments in the field, in some sense academically, came perhaps from the US and other countries in the West initially. This has also been true for many industries, right? Many of the products that we use, right, are essentially developed by companies very often, right, multinational companies, or it could be done in the future. If that ecosystem exists in India, you will see, Priyanka, you would see new products that we cannot even imagine today coming out of that ecosystem and creating a whole chain effect on that ecosystem, right? There's the demand, the supply, the sort of sending out, these products beyond, not just in India and so on, bringing in people, solving problems for both the people in India, but also the society at large. So I think you would see that automatically if we are strengthening the research ecosystem, both the education side and the investment side and so on. I don't know if that answers your question.
No, it does. I know we're running out of time, but we wanna ask you before we wrap up, Shivani, about your time at Harvard. Right, of course, a lot of our audience are Harvard alums, Harvard researchers, affiliates of Harvard. Um, Tell us about the time you spent there, how that might have shaped both the research you've done, but also your career and where you've thought about the research ecosystems that we've been discussing for the last few minutes.
Absolutely, Anirudh. Um, so I spent only a year at Harvard as a Radcliffe Fellow. Before that, I had spent time, I had either studied or taught at many institutions across the country. So I studied at St. Stephen's College at the University of Delhi in India, and then at Trinity College at the University of Cambridge in the UK, then the University of Illinois at Urbana-Champaign in the US. Right? I taught at MIT in the US and then at the Indian Institute of Science in India before going to Harvard as a Radcliffe Fellow. So I guess to many parts of my thinking perhaps may have been shaped by my experiences at these institutions by the time I got to Radcliffe. But that said, the year I spent at Radcliffe at Harvard was truly unique. The experiences I had were truly unique, and they're experiences I will cherish forever. So the Radcliffe Institute program is a very interesting program. The Radcliffe Institute for Advanced Study. I think it's now called the Harvard Radcliffe Institute. It brings together around 50 fellows every year through a sort of a competitive selection process from different walks of life, from different backgrounds, from all over the world, in fact. And for me, it was a very beautiful experience. There were diverse individuals. Many of them, due to the historic nature of Radcliffe, many of them were women. This is always the case. Not all of them are women, but many of them are chosen to be women. As somebody who works in computer science, I am typically surrounded by mostly by male colleagues. I, of course, enjoy talking with and working with my male colleagues, but this was a different experience for me. It was a welcome change of demographic for a year, surrounded by many very impressive individuals, in particular many women. I was probably one of the younger fellows that year. And so for me, I had a chance to observe and learn from more senior women around me who were committed to various causes, very diverse causes. There was somebody who was a neurosurgeon who was passionate about what she was doing. There was somebody who came from a far off country who was a lawyer who had worked very hard to fight for various types of civil rights in her country. Many, many stories like this. And it was a very beautiful experience. I think, the year I spent there reinforced and strengthened the desire that I had built from my previous experiences to expand myself and to try to contribute more beyond myself, whether it's within my scientific field or to the society at large. So that really strengthened that desire. And this is an experience that I think it was a privilege to be among such amazing people for a year. And I will always cherish that experience, Anirudh.
Yeah, yeah. I think that's something that I think both Priyanka and I would relate with. I think the time we spent at Harvard, the kind of diverse individuals that the university brings together, I think is one of the most special things about the university. But thank you so much for sharing the time and for such thoughtful responses to, I would say, lots of different kinds of questions that we've thrown at you in the last half an hour. But thank you for taking the time. It sparked off more questions in my mind also, which I'm hoping that we'll get to speak about at some point or the other. And thank you for all your contributions to this research and scientific community. I think obviously in India, but also in the US and elsewhere. And thank you for sharing the time with us today.
Thank you,
Thank
Shivani.
you, Priyanka. It was a great pleasure being with you.
We're delighted to have you, and I can see so much of your passion come through. So thank you for your time today.